Hello guys, let's start with our module 10, table relationships and joins. Let's start with the first video of the module, understanding table relationships. So in this particular video, I will try to give an overview and understanding of the what is it, table relationships and why we need it and all those stuffs we are going to understand in this particular chapter. So let's begin with it. Okay. So it would be a bit of theoretical plus some implementations if needed. So let's start. So first thing which comes to our mind is why table relationship relationships exist. Okay, so this is very important. You should know this, right? Before why we need the table relationship, why it's not, why it's necessary, right? So in real world, the data is never isolated. Okay, so it's not like that I'm Hers and let's try to understand this in this particular manner. Like I'm Hers. Okay, so I will have friends, right? I will have some relationship with them. Okay, I have my family, I have some relationship with them, I have some duty and dependencies on them, right? And vice versa is also true. So this particular thing happens in the tables also. Okay, how? Let's try to understand. Suppose it's a student. Okay, and let it be a course, then let it be enrollments. Okay, what do you see here? 1, 2 and 3. We see three tables: student, courses and enrollments. Okay, so if we store everything in one table, is it possible, like all the details of the student in one table plus the course plus the enrollments? And now there could be a scenario that the courses might get added up, right? So you will not be going to each and every students and database and keep on updating it. You will have a separate table for the courses, correct? And you will have all the courses which the college or school provides you for your education. So it is stored in a different courses table, right? Similarly, enrollments will have a different table, right? Because if I am the admin or if I am the owner of the college or school, I want to check how many enrollments are there, right? I don't want to check the student, what courses they are going on and what else, right? So all of these three tables will be different, right? If we think it as a data engineer mindset, and if someone asks you like what is the data model for it, so you're going to explain it this way, right? What is the structure going to be? So focus this as a data engineer part. Okay, so this will result, if we have all together in the same particular table, so it will result in duplications, inconsistency and messy data, right? So what we do, we split the data into multiple tables, connect them using relationships. Okay, we connect them, okay, using relationships. So these are not the hardcore nodes, so you don't have to worry about it. Okay, whenever the codes where when I'm what I meant by hardcore is basically the nodes which you specifically need to study and revise and everything else. Okay, so I tried to give you a real life analogy by taking myself as an example. So if I need suppose I'm not earning anything right now. Okay, so I will take my money from just spend money from, or allowances from my mother or my father or my big brother, right? So that I'm dependent on those people, right? And indirectly they are also dependent on me. If I am able to do some kind of work and they are not, so they are dependent on me, correct? So this is how a give and take goes. So similarly this works with the relationships in table. Okay, now let I hope you got the idea here. Okay, how why relationship is needed. Let me take another analogy here. Suppose a student, in the student table you have the details of the student, but you want to check the course of in which course he or she is studying, right? So what you will do, you will try to take something from the students tables, which is basically a primary key, and you're gonna check into the courses table, which is a foreign key of which we have already studied in our previous chapter, if you remember. So I'm gonna join them and create a third table which will have student plus the course which the particular student is enrolled in, right? So this is how it works. Now moving ahead, types of table relationships. Okay, this is important. Okay, this is important. So let's start with the first one, which is one to one relationship. Okay, meaning um, one record in table A, okay, has the relationship with one record in table B. Okay, if I go with an example here, example would be person is a table and passport, suppose it's a table B. Okay, so it has one record, it has one record, so they are matching with each other, with each other. Okay, one to one relationship. Suppose I will have, there is a 99% chance that I will have one wife. Okay, so it's so I will have one wife, so and she also will have a one husband, right, in a life current situation. So it becomes a one-on-one relationship. Okay, it's not like that. A father might have a parent might have multiple uh, children, or a father might have multiple children, so it will be like one to many relationships, which I'm going in the next one, which is the next one basically. So I'm hoping you got in getting this point right. Rather than memorizing everything, it's more on understanding the concept. Now let's move on to the next one, which is one to many. Okay, it is also written as one to many. Okay, and this is very important, so I will just, okay, make it as stars. Very simple. One record from table A, I will write in bracket table A, to many records, not multiple, many. Okay, many records in table B. So the example which I gave you already, okay, in the previous analogy, a mother might have 3 or 4 children, 2 children, even 1 children, right? So mother relationship with the children is one to many. Okay, and if you take it as a vice versa, there are multiple children with one mother, it becomes many to one relationship. Okay, so you could call it as one to many to many. Oh, sorry, one to many to one. Okay, if we take an example of a database, suppose one department. Okay, let's take a formal example to understand. One department will can have many employees, right? Example. So suppose the department is HR here and IT here, correct? Here might be 10 people in HR, in IT there might be 30 people, right? So this could be the scenario, and this is used 90% of the time in our data engineering field, or in data admin field, or whatever data you're playing with. You're creating a table, you're creating the relationships. This is the most common. So let me give you one more understanding here. Vice versa is also true. Vice versa, many to one. Okay, this is also true. Now let's go forward and try to understand many to many. Fine. Now till now you got the idea. One to one, one to many to one. What could be many to many? Example: a student. I'm a student, right? And if I can, if suppose I'm a it's in a school, okay, in a school or in a college, multiple students are there and multiple courses are there. If you see from the college perspective, there are multiple students and multiple courses, and one student might have might be aligned enrolled in multiple courses, right? Similarly, 10 students, and each student is enrolled in 10 courses, so 10 students enroll in 10 each student enroll in 10 courses, right? Got it? So if from my perspective, if I look at it, it becomes many to many relationship, right? How? Let me give an live example. Suppose student A, student B, student C, okay, and course 1, course 2, course 3. Okay, look from my perspective. A has this C1, C2. Okay, B has C1, C2, C3. C has C1 and C3. So from my perspective, A is from one to many relationships, right? B is basically one to sorry, one to many. Okay, C is also one to many. Got it? Because one to many. But if you're looking at from this direction, right? But from my perspective, if I look at it, it's like C1 is having many to one relationship, C2 is also having many to one relationship, and C3 is also having many to one relationship. Okay, so if I cross this, okay, if I cross this and if I join this NM, it basically becomes many to many relationships, right? So it basically becomes many to many relationships. Okay, I was able to explain this particular point to you. So this will require a third table also. Let me just write it here. So requires third table. Okay, it's work as a bridge. This will work as a bridge. Okay, so I was able to make you understand about the one-to-one, sorry, one-to-one, one-to-many, many-to-many relationship, and many-to-one also, the vice versa of one-to-one. Okay, so this is very clear, very easy. Okay, uh, and if you're getting confused somewhere, if you're mix up, so just look at your body and just try to think it as you have two hands. Left side should be your table A and right should be your table B, and when you join both the hands it becomes one to one. Suppose in your right hand side you have three pairs or three arms, and in the left side you have one arm, so it becomes one to many. And suppose in the left hand side you have three arms, and in the right hand side also three arms, then it becomes many to many. Okay, I hope this makes it clear. Now let's come back to our MySQL workbench to understand few of the implementation of, so that we can have the practical example understanding. So let me create a table first. Okay, let me see what tables do I have in company DB. First of all, employees. Okay, so first thing, use company DB. Okay, create table, and no syntax here. Okay, it's very straightforward and very simple. Create table departments. Then suppose I have department ID here with integer and as a primary key. Then I have department name as Vaka 50. Okay, that's it. Okay, the table has been created. Control enter or command enter. So I will name this table as the parent table. Okay, now I will create a child table here. Pasted this, and I will click control enter. Says it already exists. Yeah, since we already have this employees table here, right? Drop table employees. Great. Now again I will do this. Okay, tables has been created. Refresh this. We have two tables. Great. Now I will insert this data in the departments table. Think it's done. Yeah, and I will enter this data also in employees table. Okay, great. Now what I will do? Select star from employees. Okay, we have the data, and select star from departments. So we think it's departments. So that is also done. Okay, now let's try to understand the relationship here. What is the relationship between them? Okay, so I will just write it here. Okay, understanding relationship. Okay, in the bracket I will write MySQL part. Okay, so what I am doing here is that here, if you can focus, we have a department ID, right? And if you can check here that employee ID here is kind of a primary key, and here department ID is kind of a primary key. Fine. Okay, so department ID in table departments and in table employees, what is the role of department ID individually? If you have focused here in departments, it is a unique because I have kept it as a primary key. But in employees, I have written department ID, but it's not a primary key. Okay, so it will be a repeated one. And why repeated in employees? Because three employees might have three departments which are same, right? So it will be a repeated one. That's why. So this creates uh, one department to many employees, right? Makes sense now? Because there are only two departments here, right? Oh, sorry, three departments, and there are multiple employees. So the employees are the dependency of the parent table, which is the departments table. So this becomes the parent table, and this becomes a child table. So this makes you clear, right? That how it goes and how it works. So whenever I have to create a new employee, I have to look into the departments table to make a relationship between them. That okay, so there is a department ID has to be present here. Okay. Now coming back, now there might be a question to you. What happens if no relationships? Very important. Okay. First thing, data duplication. Very, very, very common. Then comes the update problems. Like when you try to update the data, right, it will create a lot of problems. Suppose if you're updating the course enrollment of a particular student, you have to update the date, you have to update the details of the students again. Um, you have to also update the enrollment table, the enrollment date and the course and everything. So it will be a big mess. Then because of that, it will become inconsistent data. Okay. Now, to have the understanding of this, what I will do, because I want you people to have why we have relationships in the table, right? Because everyone will come and teach you left join, right joins, the kinds of joins which are basically present in the relationships of SQL, but they won't be saying why it's required, okay? And they won't be going in depth. So what I'm trying to give here is that you know the gist and understanding of why we need relationships. Okay, suppose employee, right? This employee table was there, and in the same table, so it's column now, okay? And we have the department name. Okay, Amit is there, then suppose Neha is there and Rahul is there, and with Amit I have HR, with Neha I have IT, and with Rahul I have IT. If somehow IT is changes to tech, you have to update, you must or you have sorry you have to update or you must update all rows. Does it make sense? It's very inefficient, right? And if you tell this to the interviewer, right, he will directly reject you because this is the basic things you should be knowing, right? So that's the reason it's a bad decision, bad design. So I will write it as bad design. Okay. So to make it a reasonable one, what you will do, you will just say with relationships. Okay, what you will do, you will do nothing. What you will do, you will just create two tables, one departments, okay, and second you will create an employees table. That's it, the one which we saw earlier. Okay, got it? And departments will basically store the ones or update ones, whatever. Employees works as a reference to the department ID. Okay, so it becomes change once reflects everywhere, right? Now So because of this, relationships helps in first thing consistency, second most important thing is accuracy, third important thing is no invalid references. Okay, very important. Now this is all the understanding and the knowledge of the relationships you should be knowing. So what I am going to give you is some key terminology which you people should know. Okay, key terminology. Okay, what are those? First thing, parent table. What I will do, I will type this out. This is very important, so I will just type this out. So the term and then the meaning. Okay, okay. So parent table. So this is the term. The meaning comes out to be the main table. So I will say it as original data. Then second comes out to be child table, the example which we saw right now, right? Employees and department. This is becomes the dependent table. Then comes the primary key, unique identifier, foreign key, reference to another table. Okay, and relationship, logical connection between tables. Fine. So these are the things you should be knowing. Now, so how we do this relationship? How we make this relationship work, right? So it's the I would say the joins. Okay, majorly the joins in SQL. It's very important. So we should be knowing about the joins and EVA. Relationship does not only mean we're joining. Yeah, it in broader term or in a smaller term, if you go, it's like when we are joining two things, right? Like me and my if I have me and my friend, okay, single friend. So to take out a combined result, two things have to be joined together, right? So that is why we use the join term here, because we are joining two particular tables. Okay, so that is why we call it as joins, and mostly the relationships are done on the joins. So what I will do, I will just give you the brief of the joins which we have. Okay, which we are going to study coming going forward. Okay, so we'll just write here types of joins. And if you learn joins, right, everything becomes easier for you in relationships. Okay, and of course, first thing we're gonna learn is inner join. Inner, first thing. Second, we're gonna learn, suppose, left join, left and right join. Fine. Then we're gonna learn full outer join. Then we're gonna learn cross join. Okay, then self joins. Okay, and then comes natural join. Yeah, there is natural join also. That's it. These are the types of joins which completes all our topics of the join basically. And before that, we're going to learn about the primary and foreign key, how it works. The main purpose of primary and foreign key in the table is basically with the joins. So I will just write here as pk, and foreign key also we're going to learn, because this is very important to understand. Okay, and don't get overwhelmed by looking at all these kind of joins. Very easy, very straightforward. Okay, So this is all about table relationships and joins, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is primary keys and foreign keys. So from the chapter 1, we got the understanding of the relationships and how relationships exist, and three types of relationships are there: one to many, one to one, many to many, and vice versa, many to one. Along with that, we understood there are joins present in that, so that we can go ahead with the joins, so that we can go ahead with the relationships of the tables. We got the detailed understanding of what is relationships and joins, but why we need to understand these primary keys and foreign keys when we already have studied in our previous chapter. Look, in that chapter we understood what are those, right? But here we will see or try to explain how they matter. Okay, so let's begin with it. So let's start by understanding primary key first. Primary key. Okay, I will type these things out now. The first thing about primary key is that it is a column, of course, which is uniquely identified, uniquely identifies each row. Second, cannot be null, cannot have duplicates. We know this, right? Great. So if you go for the real life examples, it's very easy. Uh, Suppose it's roll number, employee ID, etc. Okay. So let's also see the practical example of it. Okay. Uh, okay, I'm going a bit faster here because we have already have knowledge of foreign key and primary key here, but let's do with it. Okay, so I will just create a table here. Create table. Suppose students, and which will have student ID. Okay, and then it's be integer and primary key. This is a syntax, right? I'm not taking the syntax here because we already know the syntaxes. Okay, name varchar 50. Okay, so this will help you to revise the concept of primary key. Control enter, table has been created. Now what I will do, I will insert data. Okay, I will insert this data here, this one and this one. Okay, both the data has been entered. Select star from students. Okay, look, we have the data present here. Now what if I do this, insert into student values, and again 1, it will throw error, right? Again, if I just do it this way, suppose if I enter null, it will throw error. Okay, error because error duplicate duplicate error null value. Okay, coming back to the foreign key. Foreign key. Okay, so foreign key in a column act as, or I could say, refers to a primary key in another table. Okay, you can consider this way. It also creates a relationship between tables. Okay, it refers to a primary key in another table, of course. Secondly, it creates a relationship between the tables, right? If I take a real life analogy, okay, let me, not here, I have to reduce the size. Actually, what I should be doing, I should place it here. So if I go with a real life analogy here, okay, real life analogy, suppose an employee has a department ID. Okay, when we have an order customer ID. Okay, here it is, a child is depends on parent. Now I'm giving this task to you to understand or to identify like which table is the parent table and which is the child one here. Okay. And do let me know when you have the idea on that. Okay, now let's come back here and let's try to understand the practical example. Okay, so since we have the departments already, okay, let me see the columns. Okay, we have the departments already present here. So what I will do, drop table departments, done, right? Okay, so I have pasted these things here. Now from here, which is the parent table? This is the parent. Okay, then this is the child. Okay, then we have the data. So I will do insert everything. It's throwing an error. It's saying that okay, since already have employee, I have to drop table employees. Now if I just run everything, okay, departments already exist. So employee got created, I think so, and I think data is also there. Let's see. Select star from employees. Okay, so it's throwing some error. Let me check. Okay, it got created. This also got created, and this also got created. Now let's check. Let's check in the department also. Okay, so we have the data in both the tables now. Fine. Let me give you a brief. Look, this is the department ID is the parent table and it is the primary key. Here, the primary key is employee ID for the employees table. Of course, it will make sense, right? According to the table architecture, employee ID is the primary key. But here, department ID is the foreign key which references the department ID in the create table. Okay. And there will be some scenarios that even here also we have employee ID and here also we have employee ID. Okay, and suppose here we have employees dependents detail and here we have employees detail, so both has to be have employee ID as their primary key, right? So in the dependent table, which is the suppose the dependents of employees table, in that the employee ID would become the foreign key again, right? So in that case, this particular point becomes true, refers to primary key in another table. Okay, so and these two are the valid cases to be entered. Okay, no issues here. And keep in mind here, department ID should be matching with the one present here. Okay, because if I try to enter, suppose, let me copy this, paste it here, and I'm just putting here 10, right? And we'll just remove the comma here, and I'm putting it as 103. Okay, it should throw an error or not. Let's check. It will throw an error because it says a foreign key constraint fails company DB here. Because what happens is that, look, we don't have any department ID as 10 present in our departments table, right? So that is why we are getting this error. Okay, so we'll just write it here as error. So this I'll call referential integrities. Okay, okay, error, and this is called referential integrity. Okay, coming back to the slides, and from this we come to know of a topic name as referential integrity. So let's try to understand this. Look, these are very important things. Okay, it might look some kind of an easy topic or just leftover topics, but these are the things which are asked in interview, and these are the very basic things you should be knowing. Okay, integrity, and as a data engineer field, this is very important. So what is the rule here? Okay, rule says that child table must reference valid parent data. So in our example, in the implementation, we saw that we were putting the department ID as 10, right? And in the parent table, we didn't had any department with an ID 10, correct? So let's write through the error. Okay, so this helps in preventing prevents, first thing, invalid data. Second, broken relationships. Okay, so this is a very important thing which is prevents the referential integrity. So this is the rule of referential integrity, that every child table must reference valid parent data. So this way both the table exist in a consistent manner. Okay, I will request you to go through the module 6, integrity and constraints module. The chapter name is primary and foreign key, in which I have explained very in depth about the primary key and foreign key. Also about the relationship between child and parent table, where we talked about the cascade, set, null, and restrict features of foreign key. These are the three important, chapters, or you can say three important subtopics of foreign key. So if you go through that particular chapter of the particular module, it will help you a lot to understand. Okay, so let's move ahead now. I just want to give you a clear comparison between them. Okay, the primary key and foreign key now. So what I will do, I will just write here pk versus f. Okay, let me write it properly. So we'll just write pk versus fk, and in between we'll just write versus. Okay, suppose a feature is there, and then there is a primary key, and then there is a foreign key. Now let's check. Okay, uniqueness uniqueness, then null, then purpose, then there is table type. Okay, now for the primary key, it is unique. Okay, and foreign key might repeat, okay, or can repeat. The null is not allowed, and allowed, okay, in the foreign key. Usually it's allowed. Okay, purpose is to identify a row. Okay, the purpose is to create a relationship. Create relationship. Okay, and the table type is a parent. A primary key table is always a parent, and a foreign key table is always a child. Okay, and just give this arrow marks here so that it's easier for you to read out. Purpose, and this one, and this one. Okay, so I'm not going through in depth in this particular video, because this topics has already been discussed earlier in the module 6, integrity and constraints. And if you go there and go through the video, go through the particular chapter, you will get the complete knowledge of primary key and foreign key. Okay, and so this was just of a revision and a brief for you people, so that you can get to know about primary key and foreign key. And so this is all about primary key and foreign key, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, inner join. So this is the first and the most easiest, or the simplest, or the most common join, which is used in regular basis for a SQL engineer or a data engineer, or any kind of work you're doing where we need a joining condition. Okay, so let's begin with this and try to understand how it works and what it is. The first question which comes to the mind is that why inner join is needed. Why it is needed? Okay, till now what we understood that tables are separate. Okay, relationships exist via primary key and foreign key. We have that understanding, right? But the real question is like the real questions are like, show employee's name with department name. Okay, suppose show employee name with department, okay, name. Now we know that employees table is a different one, right? This is the employees table, and this is the department table, right? So we have to connect these tables, and we know that we can use primary key and foreign key to do that. Okay, and the question is, I need the employee's name with their department name. So basically I want, suppose Harsh is there with a department as IT. Okay, so this is what is expected. How you will do that? Data is split here, right? Data is in a splitted form. So cannot get the answer from one table. We have to combine both the tables. So the solution comes here is the inner join. Okay. So what is inner join? Okay, the true definition of it. So it gives common common data between tables. Okay, why I wrote tables, not two tables? Because when we will learn these things, right, and when you will practice the SQLs and the questions which you will do, in basics you will be using two tables. Okay, but as you go in more advanced form in real world scenarios, three tables, four tables, five tables, six tables are done inner joined. Okay, that's why I have written tables, not two tables. Okay, so what we understood from here, it gives common data between two tables. So if I draw these two circles, I don't know what it is called, I just forgot the names. If I draw this, okay, please do let me know what it is called, I just forgot the names. So here both are intersected, right, and this is what the data we need. This is inner join. Okay, so this is table A and this is table B, and when I joined both of the tables, the common data between tables is this, right? So this is our output for the inner join. Let's try to understand. Example. Okay, suppose table 1, okay, departments. So I will have department ID and I'm gonna have department name, right? Look, the syntax is very easy. Okay, the syntax is very easy. The main thing is to understand the logic and the concept. Because if the concept is not clear, you can learn syntax anywhere. That's not a big deal, right? The concept has to be clear. That's why a bit of a theory portion here. Okay, 1, 2, 3, HR, IT. Okay, IT. Let it be finance. Okay, so this is the departments table. I will just okay, then employees table, employee ID. Okay, then we have employee's name, then we have department ID. Okay, we have these things here. Let me fill the data. Suppose 101, 102, 103, 104, and so 105. Okay, employee name, let it be A. Okay, B, C, D, E. I am not going to write the names here, it will consume unnecessary time. Let me put the department ID here, 1, 1, sorry, 1, then 2, then 2, then 3, then let's take this as null. Okay, it does not have any department. Now what will be the output of this? If I just do the inner join, okay, inner join, what is going to be the output? First thing, what was the question? Question was show employee name with department name. Okay, so I want to show the employee's name and department name. So employee name and the department name. Okay, so when the inner join is performed, the common data would be taken. Okay, so this is the primary key, employee ID is the primary key, right? And here this is the primary key and this is the foreign key. We have this understanding, and this department table is basically the parent table and this employee is the child table in this particular scenario. Okay, so when I this is the primary key here and this is the foreign key, so this will reference this particular table, right? We have this understanding. So 1 is present here and 1 is also present here, so we will have this particular row with us. Okay, so 101, sorry, not 101 actually. So we will have the employee A with department 1. Great. Here we have 2, right? So here also we have 2. They are matching because this is the foreign key and this is the primary key, and this is referenced to with department ID. Please recall the syntaxes or recall the concept if you have forgot. Okay, so this 2 will relate with this particular 2. Okay, so I will get B with department as 2. We have 3 here, but and before that we have another this, right? So again it will relate and we'll get 2. Then this 3 I will get D as 3, but I won't be getting 105 because the department ID here is null. Okay, and rather than writing 1 2 3, I should have written here HR, which is 1, and 2 is IT, then IT again, then there is finance. Okay, so this happened to be a inner join. Okay, can you relate this now? What we did again, if I try to explain. Oh, before that, till now I will stop here. Come back to the MySQL workbench. Okay, and first try to learn the syntax now. Then again I will go back and test your understanding whether you have understood or not. Okay, inner join syntax. Okay, so syntax turns out to be very simple. Select, okay, write the names of the columns here. Okay, and the columns names should be from the table A and table B, table C, table D, table E, whatever tables you are using, all those table names should be here. Okay, table column name should be here. From table 1 inner join, this is the keyword, right? Inner join table 2 on condition. Okay, so here what's happening is that the select part, this column, as I said, all the tables which you have written here, table 1, table 2, whatever, table 3, all the columns you can write here. Okay, from table 1, but taking the data from the table 1, and we're doing the inner join with table 2. Okay, so table 1 basically becomes the parent table here, parent table. Okay, and table 2 becomes the child table. Okay, and here we will write the condition, the join condition. It's called the join condition. Okay, now this way you won't be getting a much idea. Let's try to do something. Select employee name. Okay, then department name. First let me check. First I have to do this. Use company DB. So we're using company DB now. Let me check the tables. Department. Okay. Employees. Employee ID. Okay, fine. These tables are from the previous chapter. Okay. From suppose I will write here employees. Inner join departments. Okay. On now condition. The primary key in parent table is what? Department ID, right? So what I will do? Department ID equals to the foreign key in employees table is department ID, right? So if I run this, will it run or will it throw an error? It will throw an error. Why? If you can see here, column department ID in a clause is ambiguous because in both the tables we have the department ID, right? Now the SQL is confused. From which table you are asking me to put on this department ID, right? From which table I should be pulling this. So what I will do, we'll just copy this, paste it here, dot, and I will just copy this and paste it here, dot. Now if I run, it is successful. Okay, now we're getting only 2 results because I think the data in our that particular table is different. So what I will do, we'll just use select statement first. Select star from employees. So okay, so we already have only 2 employees. That's the reason we are getting this. And department. Okay, so though both are this, right? So what I will do, so that's why we are getting that. Okay, okay, now Here I should be writing it as like this is a condition, right? So please keep this now. One more way is there. So this you have to write a complete table name here, right? So what we can do when there are longer words, and when you don't know, or we are creating a new column from the already existing columns, if you can remember. Okay, alias. So what I will do, employees as e. Okay, as I said, you writing e directly is not a good practice, but people do though. So what will happen, I will just put here e now, and here d. If I run, it will give me no error. Okay, but if let me copy this comma and paste. Okay, if I run, it won't be throwing any error, because it will consider, because both of the columns has that, right? That's why. So to make it specific, I have to just make it e and d, and also to make it as e dot d. Okay, so that you don't copy the both the names again and again. Okay, what mistake I did again? Okay, we don't have the department name, sorry, that's why it's throwing an error. Now it's correct. Okay, so I let me add more data, I think, or it's enough. Wait, let me do one thing, let me add more data. So I've added this data, okay, to match with the example which we have taken here. So what I will do, I will run this again now. Look, we're getting Amit, Neha, Rahul. Why we're getting a different out? No, we're getting a different output. Look, HR, IT, and finance, right? So we're getting the exact output, and I hope you're getting this point now. I hope you understood the syntax also. Inner join, you should always write the name of the join here. This will always be the parent table. Again, I'm writing here, and this always gonna be a child table. Okay, in this particular scenario. So you can notice here, uh, but I think current is not included. The one with the null value is not included, right? Okay, so let's take another example. What if not an example, just playing with the things now. Just put this here, and I will just make it as star. Okay, star. We're getting all the output here. Okay, and then since department ID is appearing twice here, okay, I will write it as department appearing twice, right? So if you want to don't want to show these names here like two times department ID, right? So if you want to uh, rename it so everyone knows how we can do it, it's very easy. I will just write here employee, not here actually, and let me just copy this employee ID, right? Employee name, and you can also use the alias here. I'm not using it for the shortcut purpose currently, but here I have to use e dot department ID as employee department, okay, comma d dot department ID, comma department name. Okay, let's see if it runs. Look, employee department, correct, using alias. Now, so this was the main core concept of inner join. Okay, as always, we understood the syntax and few of the way to write the particular syntax. Now what we will do, we will go on more on inner join, more on inner join. Suppose what I will do, I will just copy this. Okay, uh, let me copy this itself, paste. Okay, and remove this, no need of this now. Great. Now if I want to put any where condition, can I do that? Yes, you can do that. Can I do group by? Yes, you can do group by. Can I do order by? You can do order by. You can use distinct. Actually, whatever we learned till now, right? DML, DDL, and those constraints, everything you can use here. Where suppose d dot department name equals to IT itself. Okay. Look, we will get only two rows now. Got it? join with where. Okay, now why it is like that? Because let me give you a recall here. Why we can use everything with join? Because if you remember the, again, from the basics, uh, execution order of SQL, it starts from, then goes to join, then it goes to where clause, then it goes to group by, then it goes to having, then it goes to select, then distinct, then it goes to order by, and then at the end limit or offset, right? And since we are using join here, look, join is present here, right? So you can use where condition, group by, having, limit, order by, distinct, select, everything will be used here, and that's not an issue. Okay, so I hope you understood this. And what, so I want to give you a practice here, that what you can do is that you can try to use whatever you have learned till now, where clause, group by, having, limit and offset, order by, distinct, everything we have learned, right? So do one thing, add more data to this particular table. Okay, if you need, add more data like 10, 20 rows more, uh, and then try to use this all of these clauses. Okay, and also you can use, let me tell you, uh, max, min, right? What we call it as, if you remember, let me point it out, aggregate functions, you can use this also. Okay, so try to use this and try to practice. Okay, now coming back and continuing our thing here, and let's try to understand the common mistakes. Okay, let's try to read this. First is missing on condition. Okay, where you will miss this, from employees or table name, inner join, table name. Okay, here you will forget, because from table name, inner join table name, then we should write on, right? So here you might forget. So that's what I wanted to point out. And let me reduce the size, I think. Okay, second is wrong column match. In the on condition, on, suppose e dot employee id equals to d dot department id. If you do this, it's wrong, right? Not, one more thing is that not mentioning the table names in on condition. This example, right? This one. Look here, you will forget, right? You should not be forgetting this. Not giving the name here, so it will throw the error, ambiguous error. Okay, wrongly using the aliases. Okay, so these are the very common mistakes people do. Now I wanted to, as I was saying again and again previously also, that people use multiple inner joins, right? So let me show you that multiple inner joins, how it's done actually. Suppose select, let me zoom it, and let me close this first, and let me zoom it. Select e dot employee name, d dot department name, l dot city. Okay, from employees e, inner join departments d on e dot department id, d dot department ID. Inner join locations. Just give an example here, okay? On d dot location ID, d dot location ID equals to l dot location ID. Now you might be wondering how the joins works, right? So first what happens? Let me just copy this, okay, and let me put it here. Okay, now let's try to understand. So how it goes is like first employee plus department is done, okay, and whatever the result is, okay, is done with the location, and this gives us the result. So if you see 1, 2, then 3, like it goes from up to down, okay. Joins works left to right or top to bottom. Okay, keep this in mind. This is very important. This is very important. Joins works left to right or top to bottom. Okay, and this is how it goes. Like the inner result, then their inner result. Okay, I hope this makes sense now. So this is all about inner joins, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is left join and right join. Okay, so in previous chapter we understood what is inner join. Okay, the common part between both the tables. Okay, so in this particular chapter we're going to look at what if we also want unmatched data, right? Like the data which is not matching with the parent table, we could say it that way, right? So let's try to understand now. So what I was saying that what if we also want an unmatched data? For example, show all employees even if they don't belong to any department. Meaning, um, this was the department table, right? And this was the employees table. Okay, and it has suppose IT, HR, and finance. Okay, and here people have IT, belong to IT, suppose HR, suppose finance, suppose accountants also. So accountant is not present in department. So what was happening earlier in the inner join was that we would be getting the results only of the IT, HR, and finance, right? Because it was present in the departments table, correct? Because this was the parent table, this was the child table. Similarly here also what will happen, this is the parent table and this is the child table, but in left join, if we just do the left join, suppose here, or suppose don't forget about the left and right join, if we do the join, okay, we will be getting from departments table IT also, HR, finance, and the row with the accountant also. Okay, but this particular row will have null value in the department's end. Okay, I know it bits not clear here, not bit clear here, but what I'm trying to say is that if we do a join here, left join or the right join, and considering this is the parent table, and when we do the join here, so we will be getting all of these departments, not only these three departments. So this is a very high level brief to understand. Okay, I will go in depth. So in this particular scenarios, when we want all the departments or show all the employees even if they don't match the department, in that case we're using this particular joins, and here inner joins fails because inner join will exclude this employee with an accountant department because it is not present in the departments table, correct? Okay, so the solution for this will be the left join and the right join. Okay, let's so move forward. Let's try to understand left join. Okay, let's try to understand this. So what does a left join do? Okay, so what it does, first thing, all records from left table Second, matching records from right table. Third, if no match, then null. Okay, this is the three things uh, what left join returns. So left join returns. Okay, so if I go in more depth, or if I try to put it in a simple line, I would say that left join left table is always fully visible, meaning if there are 100 rows here and suppose 50 rows here, okay, the resultant will be 100 rows only. Okay, because here this is the left table, this is the right table. First scenario. Second scenario could be like it has 50 left table and it has suppose 50 on the right. Okay, and the matching data is suppose in both of the tables is 20. Okay, so what will happen is that when the 20 is the matching data, so I will get that 20 matching data, okay, plus the leftover 30 data from the this left table, okay, and the non-matching data from the right hand side would become left will have here and this right will become null. Okay, meaning just keep it as very simple that left table, whatever row is there, whether it is matching with the right table or not, very simple. Okay, try to understand this way. All the data from the left table will be present there in the resultant. Okay, whether or not the data of the right table, the condition which or the on condition which we learn in the inner join, which we're putting here also in the left join, whether it matches or not with the right table. Suppose if there was 101 in left table and there is no 101 in the right table, still 101 will be present in the resultant table, but the 101 which was not present in the right table will also be present, but it will be null. Okay, let's try to understand this. We'll take a table here. Okay, suppose employee ID is the column, then suppose employee name, then suppose department ID. Okay, employee ID, employee name, department ID. Please ignore my handwriting here just in case. 101 or 101, 102, 103, 104, 105. Okay, the corresponding values would be suppose names. I'm writing it as ABCD. Okay, just to keep it simple, ABCDE. Suppose these are the names. Department ID 1 1, sorry, not 1 1, let it be 1 2, then 2, then 3, and let this be as null. Okay, one more table I will try to create here. This is done, right? So now the table would be the department table. Okay, having department ID and we have the department name. Fine, so it is 1 2 and 3, and it is HR, IT, and finance. Make sense? Now if I do the left join, okay, I'm putting this as the left table and this as the right table. Okay, now a question is that I want to look at all the employees data, whether or not the department exists in the department's table or not. Okay, so from the visual you can see that we have 1 2 3 in the department's table, but we don't have the null, right? So let's see what would be the output. Just forget about the syntax one. I will give you all the understanding of the syntax later, but concept understanding is very much important here. So the resultant table would be, I want the employee name and I want the department name. Okay, so output would be very simple. It would be 101, 102, 103, 104. Till here you are sure because you learned the inner join because it's matching with the department, but here we gonna get 105 also. With that I'm going to get the department names as HR, IT, IT again I think, yeah. Then I will get the finance, and then I'm going to get the null. Look, as I was trying to explain earlier, we got all the left data. All left data is present. Correct? We have all the data of the left here. Correct? So I hope getting the intuition here what is basically a left join, right? That if I'm doing the right join, it will be the vice versa. We're gonna see that example also. So let's get back to our MySQL workbench and try to look at the syntax. Syntax will be very simple. Select columns, of course, same as the inner join from from table name. If you want to give an alias, you can give an alias here. Okay, just I will remove it from here since we know already that we can give aliases. The left join department on condition. Okay, and sorry, why I'm writing department here, it should be table name. Okay, so this becomes the parent table, left table. This becomes the child table, the right table. Okay, got it. Now what I'm going to do, let me first do one thing. Use company db. Okay, now select star from employees. We have the data here. Select start from departments. We have the data here. Good. What I will do, I will just copy this, paste it here. The columns which I tried to give example here was employee name, right? So employee name, and I want the department name here, and I will remove this section from here. And okay, so from employees table as E, and here also joining with the departments table as D on E dot department ID, I guess, right? Yeah, department ID equals to D dot department ID. Okay, let's see the result. Look what we got. We got HR, IT, finance. Along with that, we are getting Stan with the null value also, right? Let me run these queries again so that we have the clear understanding of the data we had. Look, in the employees table, what we had these 5 datas. The Julie was 3221 and the Stan was null here currently, right? And the departments, we only had 1, 2, 3 department IDs, right? So in total, it should be returning the number of rows present in the left table, correct? So when I ran this, I got 1, 2, 3, 4, 5. Okay, so if I also wanted to return employee ID, I guess. So look, it's clear, right? So I hope you got this part here. What I will do, I will just write one more thing as a note. The resultant. Now, what if you might have a question that? So I added here this 3 rows. Okay, so let's see the data correct now. What's the data now? In department, look what we have: 1, 2, 3, 4, 5, 6, and in employees we have 5 rows, right? That too we have matching data of 1, 2, 3 only. Okay, so let's see when I run this particular ID now. This particular case now, what happens? Look, we're getting only 5 rows because this is the proof that in left join only the number of rows present in the left table would be returned. Okay, if suppose if there was 106 rows would be there, 107 id, 107. It does not matter what how many rows are there in the right hand side. Okay, so if the right hand side table does not have the value matching value for the left hand side table, so that scenario what's happening is that, look, what if I it becomes null, right? Because department was null. But what if I just add, let me just add insert into employees values, I think 106. Then there is the employee's name. I will write it as my name itself. And suppose in department I will just give 6, right? I will give 7. And we'll just close this. I think it's correct. Let's see. Okay, cannot add. Okay, I cannot add only this. I cannot add the value, of course. I can add null though. Okay. So if I add null here, if I just run it again, I added 106, right? So look, it's null. So whatever if the value in the right side table does not match, okay, so the complete the column or the table which is getting joined from the right hand side would have null in their cases. Okay, because it's not matching, right? It's a very simple thing to understand. Coming back, so what I was writing here is that the resultant table will always have rows equal to uh, the left table. We saw the example right now. Okay, irrespective of how many rows, irrespective of the number of rows in right table. Okay, please keep this in mind. So this was all about the left table or left join. Now let's try to understand about the right join. What is right join? Okay, it uh, it returns, first thing. What I could do is just let me go back. Just copy paste this here because this will be exactly the same, right? Um, only of only the I will just remove the part of left here. That's it. Okay, remove left. Matching all records from the this one. Remove this. Okay, so all records from the right table, of course, and matching records from the left table. Correct. And no match equals to null. Very simple. So again, in the simple way, if you go in a simple, very simple way, right join, right table is always fully visible. Okay. So whatever things I explained you regarding the left join, copy paste everything for the right join. Okay, the results might differ, of course, that they will be differing, but yeah, the concept remains exactly the mirror image of it. Okay, so what I will do, I will just go back here and we'll create a new slide here. Okay, and we copy this and we bring it here, paste here, and this will become just right. and everything is same, and this will become right. Okay, and before hitting the query, let's just check. In 106 records we have, and departments matching are 1 2 2 3, means 1 2 3 departments, and the other two rows are null because we don't have the department present there. And here also, if you just check, um, 1 2 3 4 5 6 departments we have, and HR is HR, IT, finance, account, support, consultant row. So since this is the right table, is currently the parent now. Okay, so I have to change that also. Okay, it should be right join. So let's see the result. Okay, look what you can see here, and what you can see the mistake here. Here, this is the parent table. Look, the parent table could be employees also. Depends upon the scenario. But when I'm trying to speak here about the parent table and child table, it means that which table I'm using as a source to join the tables. In the previous one, I was using employees as a table, right? So because I was using the left join and the table was present on the left side. And similarly, here I'm using department as the right table and I'm doing the right join. So I'm just calling it as a parent table in this particular scenario. Got the point? Okay. So we come here and if we look at it, department, uh, all look, HR is there, IT is there, finance is there, account, support, and consultant. So what you can see, all the rows which are present in the departments table is returned because you're doing the right join. And the concept, and you can also see here one more new thing, that the IT is repeating twice. Why? If you just put your common sense here, look, the two data are matching, right? So it will return two rows. Simple as that. Even in the left join, if there were suppose what we can say, multiple joins of the if there was multiple repetitive things, then the rows would have also been repeated multiple times. Okay, so I hope that is clear here. So that's why all the data from the right table is here present here. From the left, only the matching data is present and other data are as null. But we know, right, there was 105 and 106 with the data present, but still that does not have the department ID with that, so it's not matching. That's why these three rows are null now. I hope you're getting this point here. Okay, so this is the right join and the left join. Coming back, previous what I wrote. Okay, I will just write here one more thing. uh, right join, right or left joins, rows might be duplicate or repeated. We saw the example right here, that in this particular scenario we can see that the IT is coming twice when we are doing the right join because it's present two times in the left table, right? That's why it's coming two times in the while we are joining this particular table. Got it? So okay, so the right join and left join syntaxes are clear, I hope. So let's move ahead now and try to understand that. So I've copy pasted this particular data here, and the heading would be left join versus the right join. Okay, so this is a very clear and very easy comparison. You should be knowing that keeps all the rows from the left table and the right table, and missing values in the left join, null on the right, and the right join null on the left, as we saw. Most commonly uses left join and right join is rare. I will tell you why. Okay, because considering this point, 1 2 3. Okay, so there is a rule: right join can always be written as left join. So this is very common in data engineering itself, that we basically follow this kind of rule. Okay, now I will tell you how. For this kind of explanation, I will try to make one more Excel query part here. I will just copy this. Okay, and I will paste it here, and right join can always be written as left join, right? This is what I wrote here, right? How? Very easy. Here also I think I forgot to write s. Okay, and here do we have alias? No, I forgot to write here also. In the wrong way I wrote it. Okay, clear. Coming back here, so look here, it's employee, right? I'll just cut it. I'll copy this also, and we'll paste the departments here and employees here. Let it be D and let it be E. Okay, now if I hit it, oh sorry, just forgot to do the left. I forgot to write the left here. Okay, now let's check the output. Look, this output and this right join output, they're matching, right? They're exactly matching, because right join can always be written as left join. Reason is that our brain works that way. Okay, because it is easier for our brain to understand. Okay, so this is the reason. This is one of the things you should be knowing. Okay, now let's try to understand more on joins, right left joins. I hope you understood the upper one, how everything becomes left, right? Okay, and suppose I want to select something like employees without department, right? How are we gonna do that? Look, these are the things which comes from practice. Okay, you once you grab the syntax and the theory and everything, right, then when you start querying the things, right, every edge cases cannot be teached, correct? So what I'm trying to do here every time is that I'm trying to give you the common ones, because if you know the common ones, you can go with the more advanced ones. Okay, so let's go with this. Let's start from employees, employees as E, and the left join as departments as D on E dot department ID equals to D dot department ID. Okay, and we know that we can use where conditions in joins, right? Where D dot department ID is null. Now this is very important. How? Because first let's see the result. Okay, then I will try to explain this to you. Look, 105 and 106 in our raw table, the department ID was null there in that particular case, right? But if I have written here E, because you are doing the left join, right, we will get the same result, man. It does not matter. Okay, the thing is, what happens is that when we give this particular condition, it is working on the left table. So what happens, just assume it as you did the left join, you got the result, and now from that result you are seeing that where the department is null. Okay, similarly, because the order of, if you remember the order of execution, uh, how the order of execution goes, it goes from then join, and it goes to where clause, right? That means what, join is done, right? We got the table. whatever the table was. Now in the table the condition is added. I hope that makes the point here, right? That makes my point clear here. Okay. Now let's take another example. Let's just say it as departments without employees. Okay. Now what we will do? You want the department as the output result, right? That's clear because we want it from the department's end. So rather than writing here employees, I will just write departments as D and let it be E and employees. Okay. Now this is the joined done, and the resultant would be based on the departments table. If you remember the right join, and in that particular right join, I will be checking which department ID is null. Oh, sorry, which employee ID is null. Right. Let's see now. Look, everything from the departments table we got. We got the result. As suppose I will just run like we got this. First we got this. This is all this. This is the same thing, right? Wait. No, this is the right join. Where is the left join? Okay, so this one. Okay. Look here. What is written here? All the data from departments table. After returning this, what I'm saying, where the employee ID is null, right? Here the employee ID is null. That's why these three records are as an output in this particular case. Again, I will repeat because join where comes after join. That means the table is already created. Got it? Now let's come back and let's try to understand some of the common mistakes. So first common mistake is using where incorrectly. How? Just now I did the wrong one, right? Rather than writing e dot employee ID, I mistakenly wrote e dot department ID, but that will not make any sense, right? The second one is confusing join direction. Okay. Now to make it clear, table name before left join is the left table. Table name after right join is the right table. Got it? So this was all the common mistakes. Like there could be more, but those are like things when we don't know. Okay. So I tried to explain you everything about common mistakes, left joins, right joins, and some of the notes of it, and try to give you the proper examples and more on those left join and right joins. Yeah. Now I'm not practicing more here because you know already about everything now, right? Distinct, aggregate functions, and comparison operators, logical operators, right? Now inner join, left join, right join, and select statements and aggregate functions. Everything you know now. So with as I explained in inner join, now since you know everything, you can just use it here. Okay. You try and practice it more. I think I could say that way. Let's try practicing it more. So this is all about. This is all about left join and right join, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is full outer join. Okay. So till now we understood and studied about inner join, left joins, and right joins, right? And we know the difference also now about the things which are in left join and right join. So if I just draw these diagrams here, suppose for the inner join we know that it's going to match only the matching content, right? Then we know if it is a left join, so it's going to be something like this: all the data of the left plus the matching data, something like this, right? Let me increase the size, something like this. Just suppose it's completely fail. Okay, then suppose if it's right join, then matching data and the right complete data, right? So I hope this is clear. This is inner, this is left, and this is right. So till now we have the understanding of how the data is processed when we use this left, right, and inner join. Okay. The problem now is that uh, problem now is that what if we want what if we want all records from both tables. Second, it should be including unmatched data also from both tables. Okay, what if we need this? Like we need the all records from both tables. When I just say all records from both tables, it means that inner join. But as soon as I put this condition that including unmatched data from the both table, that means from the left table also and the right table also. So in that case, what are you gonna do? So in that particular case comes the full outer join. Okay. Solution for that is full outer join. So where should I write? Solution something here I will write full outer join. Okay. Now one thing to keep here in mind is that let's start with this understanding, then I will just tell you that full outer join, and this is also called as full join. Outer is an optional word here. Okay, just wanted to make that clear. So what the benefit of using the, or what it returns is that returns what? First thing, all rows from left table. Second, all rows from right table. Matches where possible. Okay. Null where no match. Meaning, if I draw this diagram, okay, I'm going to get data from the left hand side also, right hand side also, and the match data also. Okay. Suppose if the data is present in the left hand side and if it is not present in the right hand side, that data will also be returned. Okay. Similarly, the vice versa is also true. So if I keep this in one word, a simple way, full join. Now I will call this as full join or full outer join, both are same. Everything from both tables. That's it. Okay. So to understand this, let's come back here and try to understand the topic. First, let's go through the syntax here. Full join syntax. Select columns from table 1 or 1 whatever, full outer join table 2 on condition, right? So this is a simple syntax. Now just let check the data before going forward. What data we have? Select star from employees, We have this data and select staff from departments. Okay, so we have this data. Okay, so let's write down the syntax here very clearly and straightforward. I want everything currently. Now it doesn't matter whatever you write here in the left side or the right side, since you are going to get everything, right? So it does not matter which is the parent table or which is the child table in this particular scenario, or which is the left table or which is the right table. Okay, so if I just go like employees E and departments T, and the condition comes out to be E dot department ID equals to D dot department ID. I don't know why I'm getting that error sign there. Employees. Okay. So here you can see that this is throwing an error here. So if I even try to run this, it will throw an error like manual correspond to MySQL server and all that stuff. So basically it means that in MySQL we don't have any command like full outer join, or if I just write it as full join also, it's not present. So you can use this syntax in other platforms like Oracle, MySQL, SQL Server, Microsoft SQL Server, and etc. Whatever there is present. Okay, so this is a syntax you should be knowing. But what we can do? So what we can do in our case? Okay, so in our case, or in MySQL, there is a workaround for it. Okay, so let me copy paste this. Look here, what you can say: select everything. Okay, or just select the employee name and department name from employee Z and this. So what is going to return? It's just going to return me. Wait a second, it's throwing an error. Okay, let me just close this. Let me run this. See, look, it is going to. Okay, got it. I got there. Let me just do this. If he'll throw, okay, look, it's just doing the left join here. Okay, and we know the concept of left join: everything from the left, and from the right only the matching data, and if it is not matching, null. Okay, similarly if I go with this, let me close this here, and this is a right join with employees. That means everything from the department's table, right? Look, everything from the department's table. Now you try to join both of them. Okay, we'll just remove this semicolon here, and if I run this, look, everything from the left side is there, the matching records, and it's not matching, so it's null. From the right side, everything is present here, and this is not matching, so it's null here. Now you might be wondering that what is this union and where is this union coming from? Look, we have not studied about union till now. Okay, we're going to study about union after this particular module. Okay, because it comes under kind of an intermediate concept. Okay, since I wanted to let you know about how it works, so I just gave you this. This is not a, this is a workaround, or you could say that this is the way you do it, because in industries mostly full outer join is rarely performed, or it is performed in a very minimal way, because it takes a lot of space and a lot of memory and a lot of time. Why? Can you check how many rows are here? 1 2 3 4 5 6 plus 3 rows, her total 9 rows, I think, right? Why? From the number of rows you can see, and you can just say here that it returns table 1 rows return. Okay, you might have a theory that it will go like table 1 multiplied by table 2 rows. Okay, or table 2 plus the table 1 rows. Okay, but both are not wrong and both are not correct. The returned rows are somewhat between both of them. Okay, here you can see it's 6 plus the uh, 6 plus the 6, right? Here you can see that here we have 6 rows, and here we had in our departments table as 6. So it is not 6 into 6 12, right? It's not 12 rows, it's 9 rows, because they're kind of adding it, and it's not adding also properly, because if we add, it will become 12, and 6 into 6 will become 36, right? So it's somewhat between. It's 9, correct? So that is the reason people don't use full outer join when there are millions of rows and data, because it will take a lot of space, time, and everything. So it just this is just a thing you should be knowing, and it might come sometime in hand for practice. And okay, so I already explained you about the rows and stuff. Now let me explain you about the union. So I will just copy this uh, pages. Okay, so look here. This union joins two select statements. Okay, so you can just call it as A plus B. There is another term, union all. What happens in union all is that I will tell you that also. Okay, so here it joins two select statements, but there is a condition. It removes duplicate rows. Suppose if there are duplicate rows, it will be removed. But in union all, it is not removed. Okay. So this is what the use case of union is. So it's we're basically adding two syntaxes all together here to form or to make it behave exactly as a full outer join or full joins. Okay. So this is the method which is used in MySQL, and it is pretty easy if you look at it. It's pretty easy, right? You just have to write the left join and plus the right join, and just have to add it. The data from the left table added with the data of the right table, and just merge it all. Okay. I hope it might be some kind of a complex thing. Might take it a complex one, but it's not. It's very easy and very simple. If you had the full outer join, if you're not using MySQL, if you're using any other kind of a platform, and there if you can use that particular syntax which I already gave you, that will help you a lot. Okay. So I wrote here in MySQL there is a workaround for it. Syntax is the same exactly. Okay. So the databases which basically supports this query is Postgres. Okay, as I said, SQL Server and Oracle. Okay, and now since you know this, okay, you can play with it with the things like using where condition, group by condition, and all those conditions. Okay, so now let's try to understand the common mistakes which people usually do. Okay, first is expecting only matches or matched rows. Okay, second, confusing with the left join. Okay, third, ignoring null handling. Why? Null is key to understand missing data, right? So these are the common mistakes that people usually do or have. So, so I hope I try to give everything about the full outer join here. The concept, it's very straightforward and simple, right? And this is the thing. This is the actual syntax, and in MySQL, the workaround is this. Okay, using my union, and I also try to give you a brief of union and union all, like they basically add the values, and we will study about union in upcoming modules because it's kind of an advanced chapter, or you could say the advanced topic or something like that, or intermediate. So this is all about full outer join, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is cross join. Okay, so Till now, what we have studied. So let's take a recap. Okay. Uh, we understood the inner join. We understood the left and right join. Then we also got the idea of the full join. Okay, we learned basically three kinds of join. So this is the fourth one, the cross join. Inner join, we know it's for the matching data. And please don't worry, this is not a note, so this is just for explanation. So don't worry about that. This is include missing, right? In left and right join, we include the missing one also, right? Full outer join is basically everything. So we have this concept very clear. If you haven't cleared this concept, please go in my previous chapters and try to understand that and come back here. So what if another question comes is what if we want every row of table A with every row of table B. When we want this, basically, as you can see here also, this one is connected with A, B, and C, right? This 2 is also connected with A, B, and C, right? So what if we want this kind of scenario, correct? So in that particular case, we need cross join. Okay. So solution for that is cross join. So if I draw the diagram here, A and B, C, D, E, and goes here also, and here also. This comes into this. Take yellow. This goes to C, goes to D, and goes to E. Okay. What if this is the cross join? So it returns. This is done. So it returns first all possible combination of rows. Okay. Secondly, no condition is required. What do you mean by no condition required? Basically, we don't put any kind of a on condition here. Okay. So in simple terms, if I just write this in simple terms, cross join, every row is paired with every row. Make sense? So now if I talk about this is the thing we understood, right? So how many rows it's going to return? So that's an important question, right? So if I do the mathematical understanding, maths, rows returned. Suppose if table A has 3 rows, table B has 4 rows. So according to you, if you do the simple calculation, right, if each row of table A is joined with is combined with each row of table B and vice versa, so what it's going to be 3 into 4, right? So there will be total rows in the output. It's very simple maths, right? You can see the diagram here. A is connected with CDE, so 3. B is connected with CDE, so 6, right? And 2 into 3 gives me 6, right? So simple calculation. So let's try to understand the syntax of it now. Cross join syntax. It's very simple. Select star from table 1 cross join table 2. Look here, there is no on condition present here. Yeah, though you can put the where condition, but no on condition is there. So what I will do, we will use our two tables. So it's going to be select star from employees table and cross join the departments table. Okay, and here the parent child table concept does not exist, because what is parent, what is child, everything is getting multiplied here, right? Look how many rows got returned. Just count this. If I just do count star, 36 rows, right? Look, I just used aggregate function to check how many rows it returned, right? So you can do this kind of things also. It's, once you understand everything. Why 36 row? Let me prove that also. Select star from employees and then do select, since we have 6 rows here, and select star from departments. So here also we have 6 rows, so 6 into 6 we got 36, so that's how we are getting 36 here. So this is a cross join. So this is all about the joins, cross join. Okay, coming back to our slides, try to understand common mistakes. So first is forgetting join condition. Okay, sometimes you forget what is the join condition, because forgetting to write the join word there, cross join. Second is using on condition. Third, using on large tables. So we are not allowed to do that, because inefficient solution. Okay, and these are the common mistakes which people do: forgetting the join, like using just cross join, forgetting to use the cross join word, and using the on condition, since we are not allowed to use on conditions. So these are the common mistakes which people do. Okay, so there is one more add-on topic I want to explain here, is about the difference between cross join and full join. So I'll just copy pasted these differences here. Okay, so if you go with the logic, the cross join uses a combination logic, and where the full outer join does the relationship. As we remember, in cross join it's a Cartesian product, right? Number of rows of A multiplied by the number of rows in B, but this does not happen in full outer join. Neither the addition happens, right? It's something between them. Condition, no on condition is required, and a full outer join requires a on condition. Output is every row with every row in cross join, and in full outer join matched plus unmatched rows, right? And a relationship required in cross join, no relationship is required, but in full outer join, primary key and foreign key relationship is must. Okay, so this is the most common and core important difference between both of them, and you should be knowing about that. So this is the one I just wanted to give at the end, and I hope this clears the topic of cross join. It's very straightforward and very simple. Okay, so this is all about cross join, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is self join. Okay, so self join means, if you just take a meaning of this in a general English dictionary, it will be a self join, meaning joining something with self, right? So what it basically means is that till now what we have studied that uh, we join uh, two different tables, right? This is what we learned till now. Now the question comes is that what if relationship exists within the same table? Yes, this is the table, and within this table only you have a relationship. So in that particular scenarios, for example, if there is a table, employees table, and each employee has a manager who is also an employee, of course, at the end of the day. So same table, but relationship exists inside, right? That if 101 is the employee as well as manager, but 102 is not the manager, but is an employee, but the manager for 102 is 101. So this becomes a relationship within the same table. So in that scenario, the solution is self join. Okay, so let's try to study this now. Self join a table is joined with itself. Second, using aliases to differentiate. Then the third comes based on internal relationship. Okay, so a self join is a table which is joined within itself. It uses the alias to differentiate. I will explain this what it is basically, and based on internal relationships. Okay, the second point I will just explain you in much better way with an example. But before that, in short, self join is basically table talking to itself. Okay, I hope you're getting the idea here. Okay, let's come back here in our MySQL workbench. And what I'm trying to do here is that I'm trying to create a table as employee manager. And this is the employee ID, employee name, manager ID. This is the primary key, and manager ID is the foreign key which references the employee ID. Okay, so we'll create this. Okay, no database has been selected. Use company DB. Create the table. Now I will add this data here. Everything is done. Select start from employee manager table. So we have this data with us. Great. Now the problem statement is, for this I will create a new scenario. Okay, so before going into the syntax, I will just try to, it's more than a syntax actually. Okay, so before going into the syntax, I will try to give you the real example, and then we can go back to our syntax. Okay, because there is no specific syntax for it. We'll get to know how and why. Suppose our problem statement is show employee name with their manager name. Okay, so what I will do, select employee name and employee name. Why two times employee name? Because so employee name with the manager name. If I go back, look, this is the manager ID. So means Amit is the manager and employee both. So it comes under employee name. 102. 102 is who? Neha. Neha is herself an employee and as well as a manager, right? So it comes under employee name column. So I have written both. Right now I am just writing it as a noob person who does know anything. Now from things which I know, I will write that from employees table, of course, and I will join. This is the syntax, this join keyword. Since I am doing the self join with the same table, again I will write this particular table name, and condition is must manager ID has to be equal to the employee ID, wherever the manager ID is equals to employee ID. What we are trying to find here, so employee name with the manager name. Okay, great. Now if I run this, it will throw an error because not unique table alias employees, right? It is an ambiguous. So what I will do, the first employees I will write it as employee, and the second employees I will make it as manager M, and this I want from the E dot this table, and this I want it from the M dot employee, and I will make it alias as employee, and this alias I will make it as manager. Make sense? Now here manager ID will come from M dot or E dot, doesn't matter, and here I will put it as M dot. Now I will run. It's manager ID only, right? Let me copy this. It should be M, I guess. Okay, it's throwing the error here. Unknown column M dot E manager ID in on clause. So my mistake here is that I am using the employees table rather than using the employee manager table here. So that's why we were getting that error basically. So we'll just paste this here and we'll paste this here. And if I run it now, look, I'm getting the correct output. Here what it says, it says that Neha is an employee and manager is Amit. Let's check. Neha's is 101, 101 is Amit, right? Similarly, Rahul's is Amit, Simran, Neha, Karan, Neha. But for, I think, Amit and Amit, Neha, Rahul's here, Simran, Neha, Rahul. For Amit, we don't have any manager because the manager ID is null. So the query which we wrote is here is that, what happens is that, now look, when I wrote, understand this way. Okay, we'll just copy this, and so from here you can just figure out, right? There is no particular syntax for it. It's just that join condition has to be correct. We'll reduce this size a little bit more. Okay, okay. Just understand it. To understand this particular thing, just take it as this. Suppose when I wrote alias, okay, forget the rules and something, everything, forget about all those. From manager E, so one table got created. Join manager M. So suppose another table got created. Understand this way. What I'm saying, from E, take the manager ID, suppose 101, 102, suppose this was whatever there was, and compare it with the employee ID present here. Okay. Suppose this and this are matching. Then return the, from this table, return the employee's name. Okay. What is the employee for 101? And from this table, return the manager's name for 101. Got it? Try to understand it more clearly. What you are doing here, to visualize, you're just creating two tables, one named as E and another named as M. E is considered as the employees table in our case, and M is considered as the manager table. Now what we are doing in the on condition is that we're taking the from managers from employees table, we're taking the managers IDs 101, 102, 103, whatever the IDs are. Okay, let me do one thing. Just take this table, okay, and I will duplicate this table, and let me clear this. So we are taking these two tables side by side, and let me remove that also so that people can understand. Suppose this is the table. Okay, now just try to understand what is happening. So these are two tables. Okay, so what I did, I rename this table as E and I rename this table as M. Now when we are doing this from this and this and the condition, from this table I'm taking the manager ID which is null. I'm trying to match it with the employee ID present here. So here you can see there is no null employee ID, right? Fine. Then I come to this next row. Again I check this 101 and I try to match it here. Is there anywhere present? Yeah, it's present here. So as soon as this gets matched, what we select the employee name from the E, employee manager. Okay. So since this is matched, so we take the employee name which is Neha. And from here we can see 101 is here and the employee name is Amit. So we get Amit. Okay. Then we come to this. Again 101. It's matched with this. So again we will take Rahul and Amit. Okay. This is clear. Now we come again in 104 employee ID and we check. Okay. It's manager ID 102 from this table. For am.employee ID 102 is Neha. So what we will do, from E deploy the name of the employee which is Simran, and from M it should be Neha. Okay. Again 105, 102 is Neha, so I will write Neha here and the employee name is Karan. I hope this visualization helps you understand how the self join is working. Now what if the question comes that, okay, it's fine, what if I do M here and E here? Do you see any difference? It was Neha Neha, Neha is here. It was Simran and Karan, it's Simran and Karan, right? It's Amit here, it's still Amit here, it's Neha and Rahul, it's Neha and Rahul. So it became basically the opposite. The employee become the managers and the managers became the employee. It became vice versa, right? So we have to change this also from M to E and E to M, whatever it is. So this is the difference. So our mind goes much more in clear manner this way. So that's why we are following this. Okay. And this was the understanding of how the output is generated and how the self join works. So this is the simplest way I can take it, so that you can understand how the simple how the self join works. And alias is mandatory in this particular scenario. So this was the self join. And if I come back here, if I just take this, okay, I will just paste it here as a syntax. I will just say column 1, I think will make sense. Alias, okay, and alias as here I will just write the table name, table, and again column and column, and let it be alias and here also alias. Okay. And here did I use as? No, I didn't use as here. Let me use it as here, as and as. Okay. Run it again. So this is the syntax here. You can go through the syntax if you have to understand this thing. Okay. So yeah. Now let's try to understand the common mistakes. Common mistakes. First common mistake is forgetting aliases. Look, aliases in the case everywhere. You know what's aliases now, right? I don't have to explain again. Second is wrong join condition. Correct. Third is using inner join unintentionally, because we know that inner join also is similar to this particular thing, right? So please keep that in mind. So this was the common mistakes. So this is all about self join, and I hope you understood the topic. So guys, let's move to the next topic. Now moving on to the next topic, which is natural join. So till now we have learned a lot about joins, right? Uh, Inner join, left join, right joins, full outer join, self join, cross join, right? And till now every join required some kind of condition, right? Which is on condition. On condition was required. Yeah, I agree. In cross join, the on condition was not required, but other required the on condition. And cross join, why didn't require the on condition? We know very well, because it does a multiplication or Cartesian product of two tables, correct? But in natural join, this becomes sorry, but in those in which it was used, was becoming a repetitive task. Every time you have to go and write about the on condition. So what if SQL could automatically detect matching columns, right? Uh, if SQL detects automatically matching columns. Okay, so this resolution is given by the natural join. Okay, so basically natural join helps to detect automatically the matching columns from both the tables and create a join. Okay, so this reduces the repetitive work of putting on the on condition every time. So if you go in the core, natural join, if you write it this way, what it does, automatically joins table, second uses columns with same name in both tables, third, no need to write on condition. So what are the pointers? Automatically joins the tables, uses columns with the same name in both tables, right? And we don't have to write any on condition. So if I go with a practical setup, there is nothing. Look, when I say that it's you don't have to write the on condition. So what you do in the syntax? How the syntax changes? Let's understand that. Select. Let me write first here. Natural join syntax. So it goes like select star from table 1 natural join table 2. So this is the simplest syntax. Okay, and so if I just copy this and paste it here and write it right here, suppose employees table and the departments table. Look, it automatically joined the data, and if you can recall, or you might forget, no need to recall anything. Select star from employees and select star from departments. So from employees you can see that we have 1 2 3 4 department IDs. Okay, and here also we have 1 2 3 4 5 6, and matchings are 1 2 3, right, in departments. And if I go in employees, we have only 1 2 2 2 and 3. So when I run this natural join, it checks the department ID in both the columns are matching. It only pulls out those records of 1 2 2 and 3. So it's basically kind of a inner join. Okay, you're just not using any kind of a on condition here. So what happened internally is that it natural join uses the on condition. Okay, and the common columns used are automatically here is department ID, which I already explained, right? But and also you can see the duplicate columns has been removed if you use the inner join. And if I do select star, department ID will come 2 times, but in this case only 1 time it has came, or it can be same, right? Now coming back, this is syntax, there is nothing to understand, right? Now the things you should keep in mind, note. Okay, if employees had, suppose it had already employee ID, right, name and department ID, good, and departments department had department ID and name. Now can you see the error here? This too, this will throw an uh, error. So now what will happen? Now natural join, or I will write as now join will match name and department ID. But we expected only department ID to match, right? So this was unexpected. So this is the danger. Okay, this is the danger. So this will create wrong results, empty output, and sometimes ambiguous results also. So keep this in mind every time when you are using natural join. Be 101% sure that the column which is, there should be in only one columns in both the tables. If there are 2 columns, then you should keep in mind that okay, if though two columns are there, I want this kind of output. So even if name and ID is there, name and ID is there, and those are matching, so the resultant output is correct from my end. So you have to keep that in mind. But always it should be only one column in both of the each of the tables. Okay. So that's why natural join is used very less. Rather, inner join is used in case of the natural join. Now coming back to understand the common mistakes. What is the common mistakes? So first common mistake is assuming only one column is used. We know it's not true, right? It uses all common columns. Second, not checking the schema. Yeah, of course, if there are more columns, then leads to unexpected result. Third, using in production queries. Never do that, please. That's the worst thing you can do to a company. Okay, so never do that. So this was only the most common mistakes that people usually do, and this is all about the natural join. There is nothing more to understand here because it's just the inner join without the on condition. That's it. Okay, so this is all about the natural joins, and I hope you understood the topic. So let's move ahead to the next topic. Thanks for watching this module, and check out the next video in the core playlist. Explore other related modules there as well. Don't forget to like, share and subscribe.